Hi everyone, it's Ms. Haley. For today's video, I'm going to be going over the sine and cosine graphs. So let's go ahead and get started. So I just took some problems from the checkup as well as the study guide from this week on Apex, just to kind of make one concise video explaining everything instead of making two kind of longer videos. So let's first talk about what a sinusoidal curve is. A sinusoidal curve is a periodic curve, which is a repeating curve, based on the graphs of sine and cosine. So the graph of tangent and cotangent, those are also periodic curves, but we're solely focusing on sine and cosine here. So let's first graph the sine curve. So the way you can get the points on the sine curve are by looking at the function itself, so y equals sine of x. And what we can do is we can plug in values for x and then find those values from the unit circle for our y values. So let's first talk about what would the sine of 0 be, or the sine of 0 degrees. That's 0. So we have a point at 0, 0. What about the sine of pi, or the sine of 90 degrees? That's also 0. And then the sine of 2 pi is also 0. So we have these 3 points kind of on like the x-axis that intersect. Those are our x-intercepts. And then we have to figure out what happens in the middle. So what's the sine? Let's look at sine of pi over 2, or the sine of 90 degrees. That's going to be 1. And then the sine of 3 pi over 2 is negative 1. So we have points at pi over 2, 1, and 3 pi over 2, negative 1. So here we have our first cycle of our sinusoidal curve, our sine curve. Okay, and so one cycle of the sine curve is actually called a period. So how long did it take to get from one end or one endpoint to the other endpoint of this period or this cycle? 2 pi. So if you're ever asked how long a period is, that's just the length of one cycle. So I'm going to highlight this cycle right here. That's one period. But the thing about the sine curve or the cosine curve is they repeat infinitely left to right. And so I can do the exact same thing. I can make my 3 x-intercepts. I can make my maximum. I can make my minimum. And then here's another cycle. All right, and it's going to go infinitely to the right, but it also goes infinitely to the left. So here are my 3 x-intercepts to the left, and then I have a maximum, I have a minimum. And so this is probably the easiest way to graph, is by making those 5 points, those 5 key points, and connecting. And again, it goes infinitely to the left. So there's our sine graph. We're also going to do the same thing with the cosine curve. So we can do the same thing with the function y equals cosine of x, just by figuring out our points. So what would the cosine of 0 be? The cosine of 0 degrees is 1. What about the cosine of pi? Cosine of pi is negative 1, so we have a point down here. And then the cosine of 2 pi is back up to 1. Right? Now we have to think about what happens in the middle. The sine of pi over 2 is actually 0. And then the cosine, of 3 pi over 2 is also 0. So even though this kind of looks like a V, this is also a curve. All right. So this is just the curve, but we start at 1. So again, this is one period of the cosine curve that took 2 pi. All right, so I'm going to highlight one period or one cycle of the cosine curve. Okay, and then we have the same thing. We have our points up at 1. Right in the middle, we have a point at negative 1. And we hit 0, and we hit 0. Okay, and that keeps going. The same thing to the left. At negative 2 pi, we have a point at 1. Negative pi, we have a point at negative 1. And then we have those x-intercepts in the middle. And then I'm not going to draw another period, but you get the point. So now we have to talk about domain range and whether these functions are even and odd. So going back to the sine curve, the domain, remember, it goes left to right. What are the possible domain values? For sine, it's all real numbers. Because we don't have any holes, we can plug in any value for x. There's no asymptotes or anything like that. What about the range? The range are possible y values. Okay, so we can see the lowest value is -1, the highest value is +1. And those are included in our graph. So we can do negative 1 to 1 with our hard brackets. Again, for domain, we could have also done negative infinity to positive infinity in our parentheses. And then, is this even or odd? This turns out to be odd because it's symmetrical across the line y equals x, not symmetrical across the y-axis. Now, talking about the cosine curve, the domain is also all real numbers, so negative infinity to infinity, and then the range is also negative 1 to positive 1. So the only thing you'll notice about the difference between the cosine curve and the sine curve are where they start. Otherwise, they look the exact same. The sine curve starts at 0, 0, and the cosine curve starts at 0, 1. Other than that, they are the exact same curve. The cosine curve starts by going down, and the sine curve starts by going up. That's the only difference. And then this happens to be an even function because you can see it's symmetrical across the y-axis. If you folded it in half, it would match up perfectly. All right, now let's start talking about graphing some variations of sinusoidal curves. So we're talking about graphing 2 cosine x. So remember when we talked about the graph of regular cosine, okay, we start at 1, we end at 1, in the middle we're at negative 1, and then in between we have those points for our x-intercepts. So this is what normal cosine looks like. And so the only difference here, need to delete these points, or let's just drag them over here. The only difference with 2 cosine x is it just stretches the graph. So instead of starting at 1, we start at 2. We also end at 2, and in the middle we're at negative 2. But then we still have those x-intercepts in the same place. So there's one period or one cycle of 2 cosine x. It's just a stretched version. And then I'm going to do one period to the left as well. So you can see we still have that sinusoidal curve, right? I'm just going to do 2 periods of that, but it's just stretched out. So our domain is the exact same, all real numbers. Our range, however, changes, right, because it's stretched. So our range is going to be negative 2 to positive 2. Our period is again 2 pi, because it's just stretched vertically, it's not stretched horizontally. Okay, and then again, since it's cosine, we have an even function. All right, now let's talk about negative cosine. So this is going to be the exact same thing as regular cosine, except flipped, right? Because we know when we have a negative out front, it just flips the graph. So instead of starting at 1, we start at negative 1. So my point at 0, negative 1, and then I also have a point at 2 pi, negative 1. Directly in the middle at pi, I have a point at positive 1, and then I have my x-intercepts halfway through there. Okay, so here is the graph of negative cosine. I'm going to do one more period to the left. So at negative 2 pi, I have another point at negative 1, negative pi 0, negative 3 pi, oops, sorry, that was the wrong point, negative pi 1, negative 3 pi over 2, 0, and negative pi over 2, 0. So here we go, here's negative cosine. Again, our domain is all real numbers. That is never going to change. Our range is back to negative 1, 1. Even though it starts at a different point, the range values are still the same. The period is again 2 pi, and then this is an even function. All right, one more example. We're going to graph sine of x plus 1. Remember from transforming functions that if we have the 1 on the end, all right, it just shifts the function up. So normally we have the middle of the sine curve is about the x-axis, right? But now it's going to shift up. Let me see if I can shift this. Perfect. The center line, I like to call it, shifts from 0 up to 1. Okay, so now everything we do is going to be based off this center line. So we're going to pretend like that green dotted line is our x-axis. So we know that the sine graph starts at 0, 0. So we're going to pretend like that's our 0, 0. 2 pi 0 is one of our points. and then pi 0. And then normally we have a point at pi over 2, 1. Now we're going to have a point at pi over 2, 2. And then normally have a point at 3 pi over 2, negative 1, but instead we have a point at 3 pi over 2, 0. So it looks like the exact same function, it's just shifted up 1, okay? So then I'm going to do the same thing on the left side. Oh, sorry, this is hard to do when it's shifted up a little bit. Here we go. And here we go. So that is going to be sine of x plus 1. Our domain is going to be the exact same thing, all real numbers. Our range, however, sorry about that, that just cut off, but the range is now, instead of negative 1 to 1, our range is going to be 0 to 2. Our period hasn't changed at all, hasn't stretched horizontally, so it's 2 pi. And then this is going to be neither odd. Actually, no, it is going to be odd. Sorry about that. Alright, so that's the end of this week's video. I hope this made sense and I hope it was helpful. Make sure you're doing your team's work as well as your Apex work. You're almost done with the Apex and we're almost done with the entire school year, which is just crazy. So make sure to reach out if you have any questions and have a great day.